All right, so this first 4 or 5 video is going to be super quick, just these first 2 problems. You guys have used the square root property before to solve equations. What you haven't done is started by factoring. So when you are told in your homework or on a mastery check to solve using the square root property, you leave the left-hand side exactly the way it is. So it's actually okay here that you've got a constant on the left and a constant on the right. We're going to take the left-hand side exactly the way it is, and we're going to factor it down. So there's this special pattern of factoring that when we go to factor this, remember we've talked about like how to multiply to get a certain number, how to add to get a certain number. So for these, we are trying to find 2 numbers whose product is 49 and whose sum is 14, and that's 7 and 7. And if we look down at this one, we're trying to find 2 numbers whose product is 4 and whose sum is -4, and that's -2 and -2. So notice with both of these, you get the exact same factor both times. So instead of writing x plus 7, which is what this would factor to, we can actually write it as x plus 7 squared, because it's 2 copies of x plus 7. So again, that's because the 7 multiplies together to get 49 and adds together to get 14. 7 times 7 is 49, 7 plus 7 is 14. So the left-hand side can just factor like that, and then we leave the 64 exactly the way it is. Okay, so that's how you set that up. Then the square root property tells us from here to try to get the x by itself, I can take the square root of both sides. So when I take the square root of the left, the squared and the square root cancel each other out, and I just have an x plus 7 left. And then on the right-hand side, do not forget your plus or minus. That is a vital part of the right-hand side because you're supposed to come up with 2 answers. So we have plus or minus, and then the square root of 64 is 8. So last step, we're trying to get our x by itself. Subtract the 7 from both sides. So this will cancel here, and then I'll have x equals -7 plus or minus 8. Don't leave your answer like this. If you can simplify it further, you should. So -7 plus 8 is 1, -7 minus 8 is -15. So those would be your 2 answers. And you can always plug those back in and check, and I encourage you to do so. So let me just remind you really quickly how to do that. So what you do is you can take the 1, for example, and you hit this control button and then the button above the 9. Whoops, there's a glare. Store that in as x, and then you can just type in the left-hand side. So you can type in x squared plus 14x plus 49 equals 64 and do a true-false check. Hit enter, and it gets true. You should be able to do the same thing with the -15, and you would also get true. Okay, let's do this one. So same factoring pattern that we had up here. When we're trying to factor down, we want to know what multiplies to 4 and adds to -4, and that would be -2 and -2. So instead of writing x minus 2, since it's the exact same factor, I'm just going to write x minus 2 squared, and then you just leave the 13 on the right. Okay, so this one's going to be a little bit different, because when I go to take the square root, just like I did above, here the 64 came out nice and neat, here the 13 does not. Same thing on the left though, the square root and the square cancel, so I can just write x minus 2. And then here, don't forget your plus or minus. 13 doesn't simplify at all. If you can simplify the square root a little bit, do that. But here, all we can do is write it as the square root of 13. Okay, so add the 2 to both sides. It'll cancel over here. And you actually just leave this as positive 2 plus or minus the square root of 13. And that's how you'd write your answers. It's always better to have these rather than having a decimal. In the future, it'll make more sense to have a decimal, but here this is just fine. Okay, so in the second half, we're going to kind of take the technique that we just used on the first half and expand it. So we're going to be doing completing the square. So rather than starting with these picture-perfect functions like we had in the first video, we're going to start with something that's missing a piece. So we're going to look at this equation first. It looks pretty similar to what we had on the previous page, except there's supposed to be a constant here. And so that's what we're trying to figure out. What value do we need so that the left-hand side is a perfect square? So let's look back at that previous video. Remember 7 was like our magic number here, because 7 doubled to get 14, and 7 was squared to get 49. So the relationship between 14 and 7 is that 7 is half of 14. And then I square 7 to get 49. So I can do that exact same relationship here. If I take half of 16 and then square it, I'll get the number that I'm missing. So I take 16 and I cut it in half. That gives me 8. And then I take that number and square it, and that gives me 64. So the missing value that I need is 64. And if we write that, let me just show you that it is actually the value that we need. So this left-hand side now looks like this, and we'd be able to factor that down because we're trying to figure out what multiplies to 64 and adds to 16, and that would be 8 and 8. And that's what makes it a perfect square trinomial, like we had on the previous page. So again, the pattern is you take this middle number, cut it in half, take what you get there, and square it. So I'm going to write that down in our official step-by-step process here. Okay, so step 1 is you are going to find half of b. And b is the coefficient on x. Meaning like just the x term, not the x squared term. So you find half of that, okay? And then you square it. So square that number, and then what you do is you add that result. Oops, not the, sorry, 2. Okay, so we took half of 16, we got 8. We squared 8, we got 64, and then we added it. So now we would say that this is a perfect square. So these instructions just tell you how to do the left-hand side. They don't actually tell you how to solve the equation, because once this is completed, you just solve the equation the same way we did in the previous video, okay? So this first example, we're just going to figure out how to find c, that missing value. And so we're going to follow these steps. So start by finding half of b. So b is 12. So take half of that, means dividing it by 2. So we get 6. Step 2 is to square that number. So I take that 6 and I square it. I get 36. So the missing value is 36. That answers the first part of my question. Then it says to write the trinomial as a perfect square. So we have x squared plus 12x plus 36. So they want us to write it as a perfect square, so something squared. So we're trying to find what multiplies to 36 and adds to 12. And that would be 6 and 6. So instead of writing x plus 6, I can just write this squared. Now a quick little trick here. This number that I have written in the parentheses is half of this number right here. That's always going to work. Okay, example 4. We're going to solve this by completing the square. Okay, so completing the square is going to work like this. First, this is not the number that we need. So since that negative 12 is not the number that we need, we start by adding that number over to the other side. Okay, so we notice that this is not a perfect square. So we're going to start by just rewriting the left-hand side, booting this 12 over to the right-hand side. So first step, get that constant out of the way because it does not make it a perfect square. Okay, so now this left-hand side, we need to do the completing the square process. We need to figure out what we can add to the x squared plus 4x to make it a perfect square. So we're going to go up and we're going to do this procedure right here. So find half of b. So start with 4. Find half of that. I get 2. Square that number. So 2 squared gives me 4. And then add that number to what I have on the left. So x squared plus 4x, so add the 4. So now this is a perfect square, and I'm going to be able to simplify it down the way I want to. However, this is an equation, so I can't just add 4 to the left because it would make my equation unbalanced. So what I do is, since I just added 4 to the left, you have to add it to the right as well. So whatever number you come up with here, you end up adding it to both sides. Okay, like that. So now we are going to rewrite the left-hand side as a perfect square. So the trick that I told you up here, half of this number is the number that goes right here. So this is x plus 2 squared. And you can always check me on that. I'm trying to find what multiplies to 4 and adds to 4. That would be 2 and 2. So I'd factor it as x plus 2, x plus 2. And then I simplify up my right-hand side. I get 16. And then I just apply the square root property. Same thing I was doing on the previous video. So I start by taking the square root of both sides. I get just the x plus 2 on the left, and then do not forget your plus or minus on the right. Square root of 16 comes out to a nice neat 4, and then I subtract 2 from both sides. So x equals, I have negative 2 plus or minus 4. So let's get both those answers. Negative 2 plus 4 is 2. Negative 2 minus 4 is negative 6. So those are my two answers. And again, if you were doing a mastery check or a test, I would encourage you to plug these answers in and check them on your calculator. Okay, next level. When the coefficient in front of the quadratic term is not 1, so like here, we've got a 3x squared, you have to start by dividing by the coefficient. Okay, so that's like step 1. If that's anything but a 1, you start by dividing it out. Okay, so we're going to divide everything by a 3. Every single piece, and that's just because this is a 3. Whatever that number is, that's what I divide by. So this becomes just an x squared minus 2 divided by 3, so 2/3 x, and then minus 1/3. 0 divided by 3 is still 0. So that's my new equation. I divided everything through by 3 because this has to be just a plain x squared in order to do my completing the square term. Okay, so let's walk through the same steps. This number does not make it a perfect square, so I'm going to start by moving that 1/3 over to the other side. Okay, so here's where I'm at so far. I'm ready for the completing the square step. So I start with this. Completing the square says first find half of b. So I want to start with negative 2/3. I'm going to take half of that. Instead of dividing by 2, I could actually multiply by 1/2. That's the very same thing. So these would cancel, and I get negative 1/3. That's step 1 of completing the square. Step 2, square that number. So I'm going to take the negative 1/3, and I'm going to square it. That gives me positive 1/9. And then step 3, add that number. Okay, so I have x squared minus 2/3 x. I'm going to add the 1/9. And remember, because this is an equation, I can't just add something on the left without also adding it on the right. Okay, so now we're going to go through the square root property. So factor this down. So this is where my trick really comes in handy. Remember, this number is always half of this number. So half of 2/3, and it's always the number that you found in this step. So like here I found 2, and that's what went in here. Here I found 6, and that's what went in here. So we have x minus 1/3 squared equals, and then combine this up, I can write this as 3/9, and then I can add them together. So I get 4/9. Okay, next step, I square root both sides. So I end up with an x minus 1/3 equals, don't forget your plus or minus on the right, square root of 4 is 2, square root of 9 is 3. And then I can add the 1/3 to both sides. So x equals, I get 1/3 plus 2/3, that's 3/3, which is 1. 1/3 minus 2/3 gives me a negative 1/3. Okay, so those are my two answers. You could check those on the calculator if you wanted to. Let's look at a few more examples here. Okay, so this one, start with the 3. We've got to divide that out. Anytime there's something in front of that x squared, this is your first step. So x squared plus, you should have 14/3 x, because it doesn't divide evenly, minus 16/3 equals 0. Okay, just like all the previous problems, this does not make it a perfect square, so I'm just going to move that to the other side. Okay, now I need to complete the square on the left-hand side, so I want to find what missing number would make the left side a perfect square. So I start with b, take half of it, so I'm going to multiply it by 1/2. So the 14 over 2 reduces down to 7 over 1. So I get 7/3. Step 2 is to square this number. So I square this. 7 squared is 49. 3 squared is 9. And I'm going to add that number to both sides. Okay, so on the left, remember it's x and then it's this number that goes in the middle. So plus 7/3 quantity squared equals, and then you could use your calculator for some assistance here. If I multiply this by 3 over 3, I get 48 over 9. and I could add those together. So 48 plus 49 in the numerator, I get 97 over 9. Okay, next step is the square root property tells me to square root both sides. So I get just the x plus 7/3 on the left equals, don't forget your plus or minus whenever you square root. Square root of 97 does not do anything. Doesn't have any perfect square factors, so you actually just leave it like that. And then square root of 9 is 3. Okay, last step to get that x by itself, we're going to subtract 7/3. So really, there's not much we can do with this. We're just going to write the negative 7/3 and then plus or minus root 97 over 3. So as ugly as that is, that's actually your final answer. And whenever you have square roots like that, you don't want to do anything with like a decimal. You don't want to plug it in. You just want to leave it exactly like that. Okay, so last example here. Just a quick note, not all quadratic equation solutions are real numbers, so we're going to do some that have those imaginary I in there. So first example, we're going to solve it the exact same way. 11 does not complete the square, so I'm going to subtract it. Now I start with this b in the middle, cut it in half, gives me 2. Take that number and square it, I get 4. So now that's the number I'm going to add to both sides. So when I add the 4 on the left, it means I've completed the square. And then to keep the equation balanced, I have to add it on the right as well. So I can factor down my left-hand side. So remember, half of this 4 is the number that goes in the middle. And negative 11 plus 4 is negative 7. I use the square root property. It tells me to take the square root of both sides. Okay, so I always have my plus or minus. I can't do anything with the square root of 7, but since it's the square root of negative 7, I can bring an I out front, like we did in the previous lesson. Okay, so this is what I can write for the square root of negative 7. And last step is I'm just going to subtract the 2. Okay, so I end up with x equals negative 2 plus or minus I root 7. And again, just like that last one, as ugly as that looks, you can't simplify it any further than that. Okay, one more, very similar. The 25 doesn't make it a perfect square, so I'm going to subtract it. Then I want to complete the square on the left-hand side, so I start with that middle number, cut it in half, take what you get there and square it. Okay, and then that's the number that you add to both sides. So when I add the 9 to the left, it completes the square. And then I add the 9 to the right to keep the balance. Okay, so my left-hand side, I can write this as x minus 3 quantity squared. Remember, the trick is that the negative 3 is half of negative 6. And when I simplify my right-hand side, I get negative 16. So I'm just a step or two away here. I square root, use my square root property. I have just the x minus 3 on the left. Don't forget your plus or minus every time you square root. And then the 16 actually comes out evenly. The square root of 16 would be 4, and the square root of that negative 1 would leave you with an I. Okay, last thing to get the x by itself is to add 3. So I end up with x equals positive 3 plus or minus 4i. So that would be your final answer.